Hi, this is Mr. Max. So I am doing transformations. So I'm going to do all 4 transformations and I'm going to go through them all. And later on, I'm going to post a small video on combining the transformations. So here, this is just focused on doing them each and having a look at how you are supposed to approach these questions on transformations. This content obviously is also useful for all the learners who are doing transformations across all the grades. Right, so you're going to hear words like object and an image, or you'll see me writing A, B, C, and A dash, B dash, C dash, or primes. All right, those are the images that the shape undergoes after a certain transformation, or we talk about the original figure and a new figure. Okay, so we are going to look at reflection, we're going to look at translation, rotation, and enlargement. Okay, right, so let me start right off then with reflection, just a overview quickly before I get into detail. So if I bring up this blue triangle here, and you need to find the reflection. So what the reflection does, it flips the triangle over. So suppose I want to reflect this triangle about the y-axis, the line x equals to 0, that's the y-axis here. It's going to be in that quadrant there. And can you see that this is the mirror line, and every point is exactly the same distance away. All right, so if I was to do the same, and I am reflecting the blue triangle, okay, let's suppose I reflect it in the line, which is going to be somewhere here. All right, so this is the line, perhaps y equals to minus x. Well, that's going to give you that particular reflection there. All right, or ideally you can also see, well, let's suppose this triangle here is reflected on the x-axis here, and this is going to be the image. All right, so this one here will be for the image after that particular translation. All right, so again, also, if for example, if you take the same blue triangle and we had to say reflected on the x-axis, and that's how it's going to be. So a reflection, it sort of flips over, all right, the shape, the original figure. All right, so the image then becomes sort of flipped. And what is important is we're going to talk about things like mirror line. In this particular case, the mirror line is the y-axis or the x-axis. All right, so the mirror line, the distance, each point is exactly the same distance from the corresponding point. So what I mean by that is, suppose this is my point A here, then its corresponding point is this point. Suppose this is my point B here, then its corresponding B will be exactly the same distance away from that mirror line. That's exactly the same distance. And suppose that was C, its corresponding point is here. So that is what I mean by corresponding points. So we're going to have a look at those ones as well. Another one that we're going to have a look at, and that is quite a challenge for a lot of students, is rotation. All right, so we're going to talk about rotation, and we're going to talk about things like a center of rotation. Suppose this is the center of rotation here, and this is being rotated. Okay, so now here's the thing: you are rotating this blue triangle in this particular instance. I'm rotating it, and here you must be a bit careful. All right, so I'm rotating it here, and this is an anti-clockwise direction. Okay, so it's anti-clockwise, and this one here is clockwise. So you have to be a bit careful when we're going to look at also that little bit of confusion that exists when we are talking about counterclockwise or anti-clockwise. All right, because there is a little bit of a sign that you have to remember. All right, essentially I'm also going to talk about when you rotate something by 180 degrees, you realize that it passes all the points and their corresponding points. All right, they will pass through the center, ideally also allowing you to find the center of rotation. All right, so we're going to have a look at those as well. So we're also going to then look at enlargement, all right? So when we talk about enlargement here, we can refer to whether a shape can become bigger or smaller. We're just going to use the word enlargement. I'm not going to talk about dilation, all right? So when we talk about this blue triangle here, and I bring in the enlarged one, as you can see here. So this blue one here is the object, is the original one, all right? So this is the object. And this one here is the image, all right? So we're also going to look at things like the center of enlargement, and the way you find the center of enlargement is you draw corresponding, you join corresponding points with a straight line, and then you extend the line. And where the lines are intersecting, now I could have used all three, but I decided just to use two. That is normally the center of enlargement. We're going to have a look at that particular scenario as well. The next one is translation. That is nothing but the sliding movement or that the shape undertakes. It kind of glides through. So when you look at this particular one here, all right, the appearance of it stays the same, but it just glides then. It just slides through. So we're also going to talk about in terms of a vector, all right, because it moves by a certain vector. Can you see that here, the triangle here under this translation has just moved once to the right and 1, 2, 3 units upwards. So I'm obviously taking it from a certain point, all right? So when we're going to talk about that, translation is just a sliding movement. You know, it moves from one position to another position, and then you describe it by a given vector. Reflection is one that we are starting with, all right? So if you have a quick overview of what I have here, so I have a triangle ABC. I have got its image, all right? And then I have a dash line here. The dash line is what we refer to as the mirror line, or the line of symmetry, okay? And that mirror line is very important, okay? Because you're going to be using that to find exactly how far is a certain point from that line, okay? And also the line of reflection, we're going to talk about the distance that a certain point is from a certain point from the mirror line, as I was saying already, okay? So maybe I should delve right into an example. Right, so they are saying here, reflect each figure in the mirror lines that you're given here. All right, so this dashed line here is the mirror line, and we have to reflect each figure. So what we need to have a look at is how far is this particular point. Let me say this is the point A, okay, from the mirror line. So in order for me to get that, all right, I see I have to go in this direction here once, and then I have to go up there again. Right, so in order for me to find that its corresponding point, which I expect to be here, all right, so it has to be traveling the same sort of distance that it has to do in order for me to find that particular point. The same applies with this one as well. So this one we can count. So say if I wanted to find B, all right, so I count 1, 2, 3, 4, 5, all right, so I went across, so I'm going to go upwards, 1, 2, 3, 4, 5. So I expect that B to be somewhere in that particular region. All right, but we're going to have a look at a few more examples, and for you to be able to know how to get that one. Let me just bring in one more again. Okay, so here we have got the mirror line here. Here we have the shape. Remember, every point is supposed to be the same distance away from the mirror line. So this one is kind of overlapping. Can you see that? All right. So this is exactly 2 units away. That one also has to be 2 units away. And so this one is overlapping. Right. So we are going to do a question the way it involves us to describe fully the single transformation that maps A onto B. So this is my A here, and this is my B here. Quite clearly, as you can see, these 2 rectangles are reflected. Okay. So A onto B is a reflection. Now what you need to also then give is the line of reflection, and the line of reflection is the mirror line. It's also known as the line of symmetry. So in this particular case, it is this particular line here, all right, which is the line y is equal to -2. So there are two things that you need to explain mostly when you're doing reflection. You have to say reflection, and then you must also give the line of reflection. Okay. The next one I'm going to bring up here is again a rectangle, A onto B. As you can see, it looks like a kind of turn, but I'm looking for the reflection. Okay, so it is now reflected in this line. And you can see also that every point is exactly the same distance away from the line. So if I had to look at this particular point here, when I go up once, all right, then I have to go across once. So again, I go up once from my center. How far is this point from the center? Can you see that? So I'm talking about how far is this point away from the center. So it's 1 and 1. So I also have to go 1 up and 1 like that in order for me to find that particular distance. All right. So you can find it by just counting. So again, the line of reflection here, this particular line is the line y equals to -x. Okay. They have to look at my series that involves y equals mx plus c, where I talked about gradients of straight lines and stuff like that. Okay. Let's bring in the question on rotation. Now, when we talk about rotation, and this one here is a little bit tricky, a clockwise rotation has normally a negative in front of it. So clockwise rotation, so for example, if you see we write -90 degrees, we are actually saying 90 degrees clockwise. Okay, and then also an anti-clockwise or a counterclockwise one is always represented by a positive. So in an anti-clockwise sense, we say positive, or we just write 90 degrees or 270 degrees, but we then refer to a positive direction or in a anti-clockwise direction. So this one here, also make sure that you understand it. Otherwise, again, as I said, if this is a little bit confusing for you right now, you can just go ahead and write it down, but this is just worth 1 mark when you are describing rotation like that. So remember, a negative rotation is clockwise and a positive rotation is anti-clockwise. All right, so it's like the opposite. So we have an example here. They say we are supposed to rotate the triangle through 90 degrees. So we bring in the origin. The triangle is here. So the center of rotation is the origin. So what you do is you take, for example, tracing paper. Okay, so what you do is you mark obviously your center and then you trace your triangle here. Tracing paper means you can see a little bit through it, all right? And what you then do is you are going to make yourselves a north line like this from the center of rotation. Is that clear? So the idea is for that north line now, because I know I'm supposed to go 90 degrees clockwise, okay, or -90. So this has to now point to the east. So what you do is your paper, you're going to turn your paper. Can you see that? And when you turn your paper, then you trace on the new position, okay, of that rotation. That is going to be the image. This is what you can do in examination. Okay, you trace on, make yourselves an offline, and then you turn your paper. As you can see, I also turn my paper here. Okay, so you press maybe something very sharp, maybe a pair of compass, the sharp one, and then you turn your particular paper, and where it stops, when it shows now nicely to the east, it means it had made a 90 degrees turn, and then you trace that particular one, and that's going to be the new position. But one of the things I keep on saying to students when they have got this particular question and they are supposed to describe rotation, they should not spend too much time if it's very difficult for them to find the center of rotation. All right, you can have, say, rotation, and you can also maybe give the angle and the direction, and then you can finish your question paper and come back to this and play around with the tracing paper. You might remember something. All right, but don't spend too much time on a 1-mark question while you still have the rest of the stuff to do, and you can come back and you can play around with your tracing paper, and then you can find where that particular image will be. Right, so I brought in a few pointers, and this is quite important. So when the center of rotation is the origin, And I'm now going to look at rotations of positive and minus 90 degrees. That means 90 degrees clockwise and anti-clockwise, or 270 degrees clockwise and anti-clockwise. In fact, you must remember that 90 degrees clockwise is the same as 270 degrees anti-clockwise. Okay, so there are a few things that you need to know, because you don't have to do all that tracing paper stuff. Once you know the center of rotation is the origin, okay, and if something is then turned 90 degrees or 270 degrees, okay, either way, either direction, as also 180 degrees, when I have a look at it, we simply play, and I'm here now referring to if you have a coordinate, a xy plane with your axis labeled, you can actually play around with the coordinates. So let's first talk about what you realize is in the first quadrant. In the first quadrant, x and y is positive, okay? Everything that you plot here is positive for x, positive for y. And you plot anything in this particular quadrant, the x values will be negative, but the y values themselves will be positive. In the third quadrant, all of the x and the y coordinates are negative. Okay, but if you have to plot something here in the fourth quadrant, the x values are positive, but the y values will be negative. It's quite important that you know that. Right, so let's talk about 90 degrees clockwise or anti-clockwise, or 270 degrees clockwise or anti-clockwise rotation. Let's take this particular triangle here that I have said is the object. Let's write down, okay, the coordinate points for that particular triangle. So you see that I have the point 2, 1, I have the point 2, 4, and I have the point 3, 1. So if I was to now describe a rotation of 90 degrees, okay, for it to be here at A, I just swap the coordinates around. You understand what I'm saying here? So the coordinates of A here, so it has undergone a rotation. But now the only way for you to know where the new image will be is just take the coordinates of the object and swap them around. And the only reason why the x ones are negative is because in this particular quadrant, the values of x are negative. So when you do 90 degrees or 270 degrees, all right, and your center of rotation is the origin, it's all that you have to do. So let's look at B, for example. So we know that in B, the x values are positive and the y values are negative. So if I swap around, okay, so now my y values are negative, because that is what happens in this particular quadrant here. Okay, so that is how you find 90 degrees clockwise or anti-clockwise, or 270 degrees clockwise or anti-clockwise. You just, and if the center of rotation, I have to repeat this and stress this, is the origin, then you do this. But what if you have a rotation of 180? Now this one is very interesting, and also this apply when the center of rotation is the origin. All you do is here you do not swap the coordinates. The only thing that will determine is going to be in which quadrant does your image now lie. As you can see, C here is in the third quadrant, and here everything is negative. Okay, so the size is going to change. So when you do 180, you do not swap your coordinates around. The only thing that's going to be affected are the signs for that particular quadrant. Okay, so this is very interesting when you do 180 and 270 or 90 degrees, and the center of rotation is the origin. All right, let's briefly bring that back here. Now, if you have a look, you will realize that there must be 90 degrees from the object to the image when the center of rotation is still the origin. There has to be 90 degrees exactly. So that is why people will talk about drawing corresponding lines and then finding the perpendicular bisector. Okay, the same applies here. If I was to do the object to B, it has that angle that is being rotated with should be 90 degrees if you describe it, and we always give you 90 degrees or 270 or 180. That is what we are going to give you to do. Now for 180, it's very interesting. If you are now joining corresponding points, that point corresponds with this point, and this particular point here corresponds with that point. What you are realizing is all of this, when you do that, they are straight. It's a straight angle, and they are meeting at the center of rotation. So when you are definitely sure that your object it's the transformation that took place. The rotation is 180 degrees, and here it doesn't matter whether you go now 180 degrees clockwise or 180 degrees anti-clockwise, you arrive at the same place. Okay, so when you do that and you draw lines with corresponding points meeting, the center, the place where they intersect, that is the center of rotation. Right, so I have here 2 or 3 questions where I want you to rotate the shape around a certain point here. So 180, well, if you can pause and you try it on your own there, you should realize you should end up with something like that. Again, the way you can check is you can actually count. This distance must be exactly the same. All right, now let's if I take this and I draw it through, and I take this particular one and I join it with that particular one, and obviously this one and that one, you realize obviously they are all passing through the same point. Okay, so it should really be straightforward for you to find the 180 degrees rotation. A second one that I can bring in, what about 90 degrees clockwise about a point? So I have here a shape and the center is kind of inside. So this whole rectangle has to tilt to the right, as you can see. Okay, so 90 degrees clockwise. Okay, it has been written out. All right, otherwise we would just have said the same as minus 90. It's the same thing. So that is where I expect that particular one to be. Right, so when we say plus 90, remember it's the same as saying, yes, 90 degrees anti-clockwise or counterclockwise. Okay, so we have got a shape here, I've got the center here. So we are going to have to rotate it in the anti-clockwise direction. Okay, so that is what I expect you to do there. And I'm doing these particular questions because they are also in the books that you are using. Right, how do we find the center of rotation? I briefly spoke about this particular one, finding the center of rotation. If you are given 2 shapes like this and they want you to find the center of rotation, now this is where you need a ruler and a pair of compasses. All right, so what you do is, first thing is you join corresponding points. Like for example, I take these 2 points and I join them with your ruler. Okay, straight line. And you can also do with the other ones. So 2 should be enough because it's a triangle. Now, what we need to do is we need to then draw the perpendicular bisectors of these lines. All right, so you'll be drawing the perpendicular bisector. So you expect a line that cuts this line in half, okay, and makes 90 degrees. Also the same, a line that cuts this one in half, and also. Now, the point where they intersect, if you put your dot there, that is the center of rotation. Okay, and then you can do this. But again, as I said, this is a trivial thing. It's something that you have to do when you have time in the examination. But we're not going to make it so difficult for you to find. All right, so you'll need a ruler and you'll need a pair of compass for you to bisect this line and then to draw them right through. And where they intersect, I only did 2 because 2 should do it. But if you want to go join the third one, you have got enough space, you can do that as well. Right, so we have got a question here. So I've got shape C, as you can see up there, and shape D. They're saying describe fully the single transformation that maps C onto D. Now, you can obviously see some sort of rotation has taken place here. But here's the catch though. You can't really say for sure where the center of rotation is. Okay, so if I take this point and that point, all right, and I join them, and I draw a perpendicular bisector, and that is what I expect you maybe to do when you have unless you trace them both and then you try to find, you trace this and you play around with tracing paper to find more or less where the center of rotation will be. That can also work. All right, and I join the other corresponding points, maybe these 2, and I draw a perpendicular bisector. Now the point where they meet, that is my center of rotation. So you say rotation to get a mark. You say obviously from C to D, that is 90 degrees clockwise, or simply write minus 90 degrees. It means the same thing. And then obviously the center of rotation, as you can see, is by the point -1, -1. So again, you can't find that point, but you can describe it. It's better to get 2 out of nothing, all right? Out of 3, then nothing out of 3. Okay, but find that. It should not be that very difficult. You should be able to find the center of rotation in an examination question in less than a minute. Right, let's talk about enlargement. So when you enlarge, we are going to talk about what a scale factor is, how many times the figure is reduced or either enlarged. Now this particular formula, you should always use them. So when you are looking for a scale factor, you take the image, the distance of the image, a horizontal distance or a vertical distance, okay? The slant distances don't really work because then you have to use Pythagoras and whatnot, and you divide it by the object. So let's bring in, as you can see, now here it's very easy for me to find if I want to enlarge this, because I've got from the origin or from some center O here. Now, if I have to enlarge this triangle, okay, no need for me to draw lines. I can use vectors. So when you look at how far A is from O in terms of a vector, that is 1 and 2 up. All right, and the scale factor, they are saying we should enlarge it by 2. So then take that vector and multiply it by 2. Right, so what you do is, in order for you to find this particular point, then it's going to be 2 cross n1. So you're going to go 2 cross n1, 2, 3, 4. So that's where I expect my A to be now, my image. And the same I do for B. How far is B from? It's 2, 2. And I'll find 4 then. So it's 3, 4. 1, 2, 3, 4. So I expect it to be somewhere here. And that would be where my B is. All right. And then how far is C? Well, C is 1, 4. So I'm going to go 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I expect it to be all the way up there. So you can use the vectors, all right, in order for you to complete the diagram. And then you can actually then write in the enlargement of the particular question that you're looking for. All right, so that is what you expect when you are dealing with your vectors. So how far is A from O? Of course, it's 1 and 2 up. So multiply that by 2, then you have the new position for your A. All right, and do the same for all of them, and you should be able to do that. All right, because O to C, for example, is 1 across and 1, 2, 3, 4 upwards. So when you multiply that by a scale factor of 2, 2 times 1 is 2, and 2 times 4 is 8. Now find O, see the new place of OC where you have 2 places. So it's 1, 2, and 8 places all the way. All right, that should do it when you have such a particular question. Right, so 3 things worth mentioning. Here you have got the object, you have got the image. So this has been obviously enlarged, the center is given. Can you see that when it's a positive whole number, like 2, the image is much bigger, all right, and also it's much further from the center. So this is, for example, a scale factor of 3. So the way you can see it is you can take this distance here, this 2, all right? So first we start with the image, remember. So when you take the image, and it's totally then up to you. So if I was to take this distance here, and I count 1, 2, 3, 4, 5, 6. So I've got 6 blocks here, all right? And then I take the same here. Well, I've got 2, and then the scale factor will be the 6, which is the image, divided by 2. And that's how you get 3. Or ideally, you can even take this distance here, all right? And by that distance, you still get the same thing, all right? But you can't take these slant lines because it's not going to work out like that. So the center, then you expect the object, and only you're going to see the image a bit further away, all right? When the scale factor is a positive whole number, you're going to have the center, the object, and an image. Image is much bigger, it's much further from your center. Very important that you remember that. So what about when the scale factor that we are supposed to do is a fraction? It's between 0 and 1. Okay, so the image is becoming smaller. So in this particular case, the image is the smaller one here, and this one here, the object, is the original one. So what you are realizing is that the image is closer to the center, right? Not the other way around now. All right, so the image is closer to the center, and if you have to calculate the scale factor of enlargement, it should always be the image. All right, so maybe I take these 2 divided by the object, by the original one. All right, and that is 6. So when you take, for example, 2 divided by 6. Well, you end up with that particular fraction. All right, so that is what you will realize. So the center, then the image, and then the object. So the image is much closer to the center, all right, when you are when you're working with a scale factor that is a fraction between 0 and 1. The image is closer to the center of rotation, or rather to the center of enlargement, not the other way around. When we had a positive whole number, the image was the one that was further from the object, and the image was the one that became bigger. But in this particular case, when it's a fraction, you expect your image to be smaller, and the bigger one is the object. So image is much closer to the center of enlargement. Lastly, what if you are dealing with a negative whole number, for example? So I have got here the object here, and you can see I have the image here. So something flipped around here. So this is when you are dealing with a negative whole number. Your image is sort of inverted, upside down. And for you to find the center of enlargement, you can simply join the corresponding points that will pass through that same particular place. So the scale factor is -2 when you come across something like this. So what you realize here, that you are having your image, then you have your center, and then you have the object. So the center is sort of in the middle of the two, and the two shapes are sort of inverted, okay, from each other. All right, that is when you are dealing with a negative whole number. Okay, it's quite important that you remember that. All right, so let me bring in a question here. Now, what we have here is we're supposed to enlarge this shape by a scale factor of -2. So there is our center here at C. So we are going to sort of enlarge this thing. So what is important here is for you to find where the corresponding points will be. Now, what is quite important when you enlarge, and I see I have a -2 here, so it's like this shape will be flipped. That's one thing I know. All right, and every point is exactly now going to be, that number of times away from the center. So what I mean by that is, if you were to check how far is this particular point, all right, from the center, well, if you go across, you're going 1 across, then I expect you, right, to go 2 upwards. Okay, so when you go down, I expect you to go 2 to that distance. All right, so I'm going to show you step by step so you can get them right. Okay, right, so let us find the corresponding points, and then you will see. Right, so the first one obviously is way up here. So this is how far this particular point is going to be from there. So if you see you're going 1 to the left, right, that means I must go 2 to the right. If I go 1 down, it means I must go 2 up. It's always like the opposite side. Okay, I'm going to repeat. I'm going 1 to the left, I must go then 2 to the right. And I'm going 1 down, so I must go 2 up to find that point. So if I have to find this particular point here, okay, so I'm going 1 to the left, so it's 2 to the right, and I'm going to go 2 places down, so I'm going to go 4. 1, 2, 3, 4. And you can find the next one, and you will realize that it's going to be exactly the same distance. All right, so let's talk about this particular point. Now, this is the point that is missing. So how far is it from the center? Well, it's 2 to the right. Okay, so I must go then 4. 2 times 2, 2 times 2. I must go then 4 to the left. Okay, sorry, it's 2 to the left, so I must go 4 to the right. So it's 2, 4. And it's 1 down, so it must therefore be 1 or 2 up. Okay, so that is how you find those particular points then. Then you take your ruler and you join it, and you must realize that they are inverted. Again, if you want to check, you can obviously also join the corresponding points. Again, they will pass through that center and so on and so on. All right, so you can pause the video, start again, have a listen to what I said. So remember, if you want to find, for example, let's label this particular point here A. All right, so look how far is A from our center. So I go 1, 2, I'm going to the left. Are you with me? I go 2 to the left, so multiply 2 times 2, which is 4. So I'm going to go 1, 2, 3, 4 to the right, opposite direction. Okay? And then let's see how far is it again then when we go on top. So then you go 2 upwards. Can you see that? So you go 1 and then 2 upwards. So now it means we have to go then down the opposite direction. So I have to go 2 times 2, which is 4. 1, 2, 3, 4. And this is where that particular point will be. And so on. And that is how you do it for that part. So let me bring something similar back here. Now, here what I want you to do is, that is the object and that is the image. So we are now here supposed to find the center of rotation. Now again, finding the center of enlargement rather, you take corresponding points like the way I'm doing here, and you're going to join them. All right, so you join this one with that one, you can join this two together, you can join this two together. What you are realizing is where they are intersecting, that is the center of enlargement. And because the shape has been flipped around, you know your center of enlargement has to be negative. All right, so how do you then find the center of enlargement? Remember, it's the image, so you can take this distance here, 1 2 3 4 5 6 7 8. So this is 8 blocks. All right, and I find this distance here, which is obviously 4 blocks. All right, so then my scale factor, now I know it has to be negative, so 8 divided by 4. All right, so it's going to be negative 2, for example. So that is the center of enlargement, and the shape has been flipped. You definitely know you are dealing with a negative scale factor. All right, so let's quickly bring in a question here. Now, I am just doing this like for, it's good to know how to find the fraction when it's negative, all right? So this B here, and that is A. So that is the object, and this is the image, which means we want to know, all right, the coordinates of the center of enlargement. All right, so this is the original one, and this is the image, okay? So to find the center of enlargement, you take corresponding points with your ruler, you mark them like that, and you join them. And where they intersect, so I'm just going to do those three. And as you can see, they intersect here at the point -1, 0. So that is how you find that particular question. Now, here's the thing now. You now have to find the scale factor. And in order for you to find the scale factor, you can see that this is an upside down story here. So perhaps you can take this distance here versus this distance here. It's totally up to you then. But you're going to take the image, so that is 1. So remember, it's negative, so it's 1. And this one here is 2. So my scale factor will be -1/2. I could also have taken that distance here, right, with this particular distance down here. All right, so the idea is for you to actually find a proper horizontal distance by a horizontal distance. All right, or not a horizontal by another horizontal, but you can't use these slant ones. Okay, this ones is not going to do you any good. All right, so the scale factor of enlargement therefore has to be -1/2 if you simplify it. So suppose you are dealing with something like that, you can also have a fraction and it's inverted and you expect it to be negative. So that brings me to, let us quickly do a quick revision, how to find the center of enlargement. So I have got here 2 triangles. Here's the object and this is the image. So again, you draw straight lines from B dash to B, you draw from C to C. 2 is enough. All right, you extend those lines where they meet, that is the center. And then you give that particular, if it's a coordinate point like what I've done here, the point -3, -3. Right, so we also briefly spoke about how to find the center of enlargement. Again, it's vertical distances divided by vertical distances, or horizontal distances divided by horizontal distances. These slant ones will not do you any good because then you need Pythagoras in order for you to find that, and that is too much work, okay? So AC, this one here, 6 blocks. This one here is 3 blocks. And that already gives me image over the object. Always remember, is image over the object, not the other way around. And this is 2, that is the scale factor. All right, use the formula. It's very useful. It's going to save you a lot. So let's talk lastly about translation, that sliding movement that we say that the shape um, sort of undergoes, right? It moves to neutral position, no turning, no reflecting, all right? No stretching, no shear. We're not doing those. All right, so we use a vector to describe that movement. So when we look at this is A, B, C. This is the object, and that is the image. All right. So when they ask you to describe the transformation that maps A, B, C onto A dash B dash C dash, obviously you say translation, you get a mark. So now let us take these points C and C. I could easily have taken B and B dash. So if I look at C to C dash, all right. So I get 1, 2, 3, 4. Okay, and 2 up. So that gives me the vector. I could have done that with point A and A dash or B and B dash. That is the vector. 1 mark for doing that. All right. So take 1 point and you do that. You should be, because it's a sliding movement, and that is how you find the vector. So when you describe translation, and here's the thing that I need to emphasize, and I saw that in one test, it is not translocation. Okay. You do not get a mark for writing that stuff down. It's translation. So make sure you get it right, and then also describe the translation by a vector. Okay, very important. Right, so here I have a question that I say, or I rather say, translate this figure by this vector. Now, it's very easy for you to see. You have to go 5 units to the left and 3 units down. All right, so you take 1 point at a time. So if I decide to take point D, that is 1, 2, 3, 4, 5, and 1, 2, 3. Okay, so point D, a little bit of an error there. Okay, so once you do that, you take a point at a time. All right, so point D, for example, you can find the image then of D. So it's going to be 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So it has to be -5 for each of them. So let's look at E. It's 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So that vector then is -5 and negative. So here you are supposed to translate the object by the vector given. So here's the vector 4, -5. So that means you go to 4 units to the right. So you can choose any particular point. So I could easily then decide if I want to know, let me see quickly, if I want to know, let's say this particular point here, and I want to move it by this particular vector here. So it's going to be 1, 2, 3, 4. And because it's negative, so I'm going to go down 1, 2, 3, 4, 5. So this is where my A will be, and you do the same for all of those points. All right, eventually you should end up and see that it should be somewhere down there. Let's bring in another one. Okay, so here we have got a triangle, and here we are saying you are supposed to move by the vector -6, 0. So negative means you have to slide now. Okay, you slide to the left. You are not going up or down because this is 0, so it's simply sliding. So again, you could easily have decided, wait, you say to yourself, okay, let me choose a point. All right, so maybe you choose this particular point. So let's call that point A. All right, so we're going to 6 places. That's 1, 2, 3, 4, 5, 6. So there, that point is going to be here. All right, and then this is obviously going to be your B. So 6 places. It's 1, 2, 3, 4, 5, 6. So your B is going to be way all the way here now. Okay, and as you can see, this one here, if this is C, then it's 1, 2, 3, 4, 5, 6. So our C will really be up there. Then you can actually now join your shape. Okay, you join your shape, and that is where you expect that new shape to be. All right, so you can do that once you have everything.